Okay, in today's lesson, we're going to talk about a method of factoring called group factoring. Group factoring is primarily used when you cannot common factor. Okay, you can't common factor. There's nothing that all of the terms have in common. If you want to take a quick glance at our first example, you can see that there is no numerical coefficient that they have in common, and that there is no one variable that every single term has, because our 6 is left without a variable. So we can't common factor here, we're stuck. Our goal, however, is to use smaller groups to factor, and I'm going to use our first example here to walk you through what to do. We are going to separate our polynomial into two groups. Usually, and like 99% of the time, this is done just this way, where you put the first two together and you put the second two together. Our goal is then to common factor within each of these groups. So I'm just going to write that off to the side here. Common factor within groups. So let's take a look here. 8x squared minus 16x. Well, I can pull an 8 from both terms, and I can pull an x from both terms, and that leaves me with x minus 2. Okay? Now I'm going to common factor my second group here. I can pull out a 3 from both terms, so I'm going to do plus 3, and then I'm left with x minus 2. Well, lo and behold, look, we now have something in common between our two groups. We have an x minus 2. This is your goal, is to find something common between the two groups. Okay, in this case, it's x minus 2. Now, if you can't find something common, try rearranging the middle terms. Okay, usually this works out, and very rarely do you not find something common in the very first step, but you occasionally will need to swap these two in your equation or in your polynomial in order to successfully do this. Now, I want you to consider, okay, we have an x minus 2 in our first term, and we have an x minus 2 in our second term. I can factor out x minus 2 from my polynomial here. So I'm going to factor out x minus 2. I am left with an 8x and a positive 3. And bada boom bada bing, we are now fully factored. So in this step, I factored out the common group. Let's consider, for example, the exact same problem. In case you're not convinced, you can do what I just did. I have 8x squared minus 16x plus 3x minus 6. I grouped my polynomial into two separate groups, right? I said we would be cut down the middle and have two groups here. I then common factored out within my first group. So I said this is the same thing as 8x, x minus 2 plus 3, x minus 2. That's just a simple common factoring step. But watch what happens next. Instead of dealing with this hot mess of x plus 2, I'm going to replace that with a new letter, and I'm going to say a. A is equal to x minus 2. So now my polynomial becomes 8xa plus 3a. Well, now I can common factor this. I can pull out an a from both terms. They have that in common. That leaves me with a times x plus 3. But remember that a has a meaning. A is equal to x minus 2. So I'm going to replace that back in, and that way we're dealing with all of the same terms. X minus 2 times x, or 8x plus 3. And just like that, we have arrived at the exact same conclusion. If this method makes more sense for you for now, where you introduce a new variable, absolutely, by all means, go ahead and do that. Let's get back to some other questions here. 6y squared minus 10y minus 9y plus 15. Okay, remember, first things first, we need to split up our polynomial into two groups. 6y squared minus 10y, negative 9y plus 15. Okay, let's common factor my first group. 6y squared minus 10y. Well, what do they have in common? They have a 2 in common between the 6 and the 10. And they also have a y in common. I'm left with 3y minus 5. Okay, now typically you are always, when you're factoring your second polynomial, or your second group here, you want to be keeping the sign that is before the first term. That's just going to help maintain that we land at the exact same group. Here I'm going to consider first, I'm going to do 9 and 15. What do they have in common? Well, they have a 3 in common, and because it was a negative sign, it's going to be a negative 3. They don't have any y's, so I'm just going to leave that as that. Negative 9 minus negative 3 is 3, and then there's a y. 15 divided by negative 3 is negative 5. Now, if we had not factored out a negative 3, I would have negative 3y plus 5. And you can see that those terms would not have been the same if it had been negative 3y and plus 5, which is why it's important to maintain the same term in the middle there, or the same addition or subtraction. Now that I have my group, my second group as being the same, I can go ahead and common factor that. So I can say 3y minus 5 is what these terms have in common, and I have 2y minus 3 as being my second group. So it's always everything that is on the outside of the brackets is what lands in your second bracket there. Okay, let's look at this next problem. 5x cubed minus 5x squared plus 5x minus 5. Group factoring, as I had said, was when you can't common factor, but we can already start by common factoring. So let's go ahead and do that. I'm going to common factor out of 5 from my entire polynomial. I am left with 5 times x squared x cubed minus x squared plus x minus 1. I'm going to group my first and second halves of my polynomial together. I have a 5 between an x squared or x cubed and an x squared. I can pull out an x squared. That leaves me with 1x and then a negative 1, because negative x squared divided by x squared is negative 1. There is nothing that these last two digits or these last two terms have in common. All they have in common is a 1. That's it. That's all that they can bring to the table. So I'm going to do plus 1, x minus 1. And very fortunately, our second two groups here are identical, and that's why I was comfortable doing that. This lands me with 5x squared plus 1, x minus 1 as my final solution. And for our last example here, I have xa minus 6x plus 6y minus a. A lot of different letters coming at us here. We're going to follow the exact same strategy. Let's group our terms together. Start with the first one. What do they have in common? They have an x in common. That's it. I'm left with a minus 6. Let's now consider our second group here. There is nothing that they have in common. So I need to factor out nothing. I can do a 1. 6y minus a. But hold on for a second here. There's not a lot that I can do. Okay, little typo here. I forgot the y in our a term. So 6y minus ay. Okay, so that changes this ever so slightly because now I can factor out a y from both of these terms, from 6y and negative ay. I can factor out a y. That leaves me with 6 minus a. But hold on for a second. Is a minus 6 the same thing as 6 minus a? Well, let's just give a number, for example. Let's say a is 1. 1 minus 6 is negative 5. But 6 minus 1 is 5. Those aren't the same thing, and therefore a minus 6 and 6 minus a cannot be the same answer. A minus 6 does not equal 6 minus a. But in order for us to do this, I need to put I need my second group here to be identical to my first. So what do? When you're faced with these types of scenarios and you need to rearrange, we're going to just swap them around. The only way to do it is to factor out a negative 1. Okay? And I'll show you what to do. Let's just continue here, xa minus 6 plus y. If I factor out a negative 1, an invisible negative 1, 6 divided by negative 1 is negative 6. Negative a divided by negative 1 is a. So I common factored out a negative 1 that more or less came out of nowhere, but it was something that we needed to do. I'm a little bit closer now because I have a negative 6 and I have a positive a. So let's just finish this out. I'm going to rearrange this so I have a and then a negative 6. And now we can see our groups are the same. Not so bad. I have a y and a negative 1. I can just multiply those together. Y times negative 1 is just negative y. And now this looks like a problem we've seen before. My two groups are identical to one another. So I can factor out an a minus 6 and I'm left with x minus y. This factoring out a negative 1 trick will come in handy when you are ever faced with situations like this, where your terms seem backwards and when minus signs, when negative signs are involved. If it was addition, it wouldn't be a problem, but it's because it's subtraction that's making it a little bit difficult. Great work, everyone!